consistent, really getting at the need for consistent and data-based expectations. I also have to acknowledge that this work was done in collaboration with one of my grad students, Patrick Ehrman, and this is all included in a recent brief that was released by the Big Ten Early Learning Alliance. So I want to start with story time. I do a lot of work around children's picture books, but I think stories really help us to understand the purpose and the importance. Several years ago, my oldest son, who's now in seventh grade, but 7 or 8 years ago when he was starting kindergarten, or before he was starting kindergarten, we went to the kindergarten parent roundup night where they were talking about all the things that kids needed to know before they got to kindergarten. They had a long list of topics for early reading. They had several things for behavior, and then they got to math. And they told us that they basically needed to be able to count to 10. And that was about it. And I having been in this field for for a good while, I knew that there's a much wider range of things that kids needed to be able to do, as well as I wasn't quite sure that 10 was as high as kids needed to get to. And so I had said to my lab, I think that there's a lot more that kids should be able to do. Let's use some data that we have and take a look at this. And so this actually led to a couple studies that were led by one of my former postdocs, where we mapped out the alignment between children's numeracy performance and the kindergarten Common Core standards, as well as mapping out what kids could do across their time in preschool, across a lot of basic counting, comparison, early addition skills, to kind of show where should kids be across these different ability levels. And that kind of led us to recognize that some of the standards that we have in kindergarten are actually below the level of what kids can do even before they get out of preschool. And so that caused us to start taking a look at, well, what are the expectations in preschool? Do we have the right expectations there? And what we were seeing was that most states, they developed their own early learning standards independent of each other. And a lot of the development of those standards were based off of when they were developing their own pre-K programs. And the standards were done in different ways. They had different groups. Some had experts and expert teachers, expert researchers, and others. Some used data to make their decisions. Others used a wide variety of sources, and they all had somewhat different goals as they were creating them. There's a recent study out of NC State that showed that there's a lot of overlap between pre-K and K standards in their state. In fact, for numeracy, there was an overlap of 62% between the standards that they had for preschool and kindergarten in numeracy areas. So over half of what's being expected in preschool is being repeated in terms of the standards for kindergarten. And so what we decided to do was a comparison of the numeracy standards across the Big Ten states, looking at several different key factors. First, one of the key areas that we were looking at is the definitions of age range, because you'll see in a second that there's a lot of variability in what different states list for the age ranges included in their standards. And then we looked at the variability in the level of expectation across several different standards, the precision of the language that they're using in defining the standards, as well as the content that's included for different standard areas. One of the things that I want to mention is that we do have a much wider range of topics that we compared, but I'm pulling out just a few specific areas and a few specific examples to really kind of show you what is this range of variability that we have. So starting out, when we talk about the age ranges, one of the things that we'll notice is that different states include different age ranges for their early learning standards. For example, Illinois just has 3 to 5-year-olds, whereas Washington has 0 to 5-year-olds. And there's even more of a range across states. Some states don't even break it down specifically in age. They use more nominal categories using names. There's also varying age brackets at which the different states break up those different age ranges. For example, California uses 3 to 4.5 as one of their brackets, and 4 to 5.5 for another, whereas Iowa uses the broader range of 3 to 5. Minnesota, on the other hand, uses 3 to 4 and 4 to 5 years old. Indiana, where I'm at, they actually don't use any specific ages for ranges. They talk about older preschool and younger preschool because of that variability in children's ages across that time period. And so it's difficult to even directly compare across states, but what we did in most cases was we took whatever the oldest age category was to use for that comparison. So starting at the variation standards, I want to start with, this is verbal counting. Count as high as you can, starting with the number 1 and go. And what we see is that most states generally say children should be able to count up to 20. There are a couple states that say 30, some that say 10. Some have a little bit of variation in saying that up to and beyond, or counting up with errors. And then we do have one state that says kids should be able to count up to 100. So we see a lot of variability. We see some consistency, but mostly there is a lot of variability in what different states recommend. Similarly, for counting objects, so this is giving children a set and having them being able to count out that specific set of numbers, a really key early cardinal knowledge ability. We see that a lot of states say that kids should be able to count out sets of up to 10. One is up to 20, but some are at 5. Some don't even have this as a standard. And some also include specifying the type of formation that kids should be able to count these in. When we get into precision of language, we see a lot of variability as well. For example, in this naming numerals, so children being able to see a numeral and being able to identify its name, we see some states that say that they should be able to count, like California, for example, the first one over on the left, they should be able to count or should be able to name all numerals 0 to 10, whereas Iowa is all numerals 1 to 10. However, there are some states that say they should be able to name some numerals from 0 to 10. But there are also states that say that children should be able to name numerals, but don't give any specific range of what they should be able to name. And this variability leads to different expectations of what children should be able to do across different states. And then when we get to inclusion of different types of content, moving over to basic standards for comparing and sorting shapes, a lot of states include both, are doing this for both 2D and 3D objects, but there are a few that only emphasize 2D objects. There are a couple that don't include this at all as a standard. Similarly, for patterning skills, about 2/3 of the states in the Big Ten say that patterning have standards for extending patterns, but 1/3 of them don't have those patterns. And so we see a lot of different types of variability. And one of the other things that really struck us is that there's a lot of inconsistency in this inconsistency. If you look at this table, what we did was we looked at what is the most common standard across a common expectation across all of these states for each of these topic areas, and we put an X if a state had that expectation, and we see very little consistency across the states in terms of which ones they were at that most common for. In fact, no state shared all 5 of the most common ones. At best, there were 4 that they would share. And so there's a lot of inconsistency in the inconsistency. Overall, some of the key takeaways from this are that early learning standards are intended to lay a foundation for school readiness and long-term success, but each state has their own standards. And these standards really vary across level of expectation, precision, and inclusion of content. And what we really need to do as a field is work together across states to develop more common and consistent expectations for early learning standards. So I'm going to stop sharing, and I believe that we'll move over to Dr. Missall now.
All right, that looks promising. Hello, I'm Kristen Missall. I represent the University of Washington on the Big Ten Early Learning Alliance. And when I'm not doing that, I'm a professor in the College of Education at the University of Washington, and I direct our school psychology program. Today, I want to introduce you to LLAMA, a math assessment tool for preschoolers. LLAMA is in its final stages of development. Here, if I can get all my things going. Oops. Okay. LLAMA is made possible by a team of 4 principal investigators, including my smart friend David Purpura, who just spoke with you, Robin Hajnowski at the University, at Lehigh University in Pennsylvania, and Tony Albano at UC Davis in California. LLAMA is also possible because of funding from IES, the U.S. Department of Education, many graduate students, and hundreds of preschoolers and their teachers and families from a variety of preschool settings, some of which you can see listed here. We launched our work to develop LLAMA because the 4 PIs on this project shared and continue to share a common commitment to the importance of early math development in preschool. And we have this commitment because first, we know that opportunity and achievement gaps emerge very early on in math, just as with reading, gaps between young children can be seen in preschool as early as age 3. And in particular, we also know that preschoolers with delays in developmental needs tend to learn math at slower rates than their peers. And so taken together, for most of our preschoolers, the need for early math instruction is quite urgent. Furthermore, based on developmental and educational research, our team believed 2 things. First, that developing an assessment tool linked to instruction would be useful and meaningful for preschoolers and their teachers and families. And second, that a multidimensional math assessment tool was needed. So presently, we have access to quite a few early math assessments for preschool-age children, but the available tools tend to be both diagnostic and deficit-based, as well as narrowband, meaning that they most actually really focus on the assessment of early numeracy skills. And we know that preschoolers have more depth of knowledge with math development than just in early numeracy. And also the available tools tend to be expensive, long to administer, and normed on unrepresentative groups of preschoolers, which is problematic when many preschool programs are compensatory in nature. So taken together, the importance of early math and the limited and narrow assessment for preschool math led us to develop LLAMA. LLAMA is a tablet-based pre-K assessment inclusive of numbers from numeracy, shape and space or early geometry, pre-algebraic thinking, and measurement domains that's administered for the purpose of universal screening and instructional planning for all preschoolers. Oh, sorry about that. So we are in our final year of funding on the LLAMA project. And to date, we've collected data from probably well over 700 preschoolers, we'll say, and their families and teachers, as well as information along the way from experts in early math development, assessment, and instruction. And we've used iterative designs for LLAMA research and development in every year of our project, which has really allowed us to be responsive to feedback from our participants, all the way from the preschoolers to the experts. And we've been able to improve our a product and our thinking along the way. So in the early years of developing LLAMA, we reviewed lots of sources of data, knowing that we didn't need to reinvent the wheel in terms of what the knowledge base around early math development. And so we reviewed consensus documents and research evidence, both theoretical and empirical for math. We reviewed IES teacher practice guides and the early learning standards. We specifically focused on our 4 states, but just what David presented, we focused on what the expectations were for our 4 states, Washington, Pennsylvania, Indiana, and California. And we scoured what was available in terms of math assessment for preschoolers. And so LLAMA content is based on that systematic review that really helped to clarify those 4 early math domains that are appropriate for preschoolers, that I named: numbers and operations, shape and space, measurement, and pre-algebraic thinking, which, by the way, is mostly about patterns for preschoolers. But in each of these 4 domains, we created developmental learning pathways of skill progressions for preschoolers with corresponding task models, and ultimately we wrote items for that entire progression. For example, in the domain of pre-algebraic thinking, and thinking about the learning area of patterns, we wrote many task models with multiple items for various patterns that would effectively increase in complexity. So items that might assess a child's knowledge or ability to create AB patterns, all the way to more advanced patterns like AB, ABC, ABCD, for example. And then we tested each of these items for possible inclusion on a LLAMA assessment. And teachers and experts worked with us along the way to confirm all the steps, all the work we were doing. So in total, we wrote 219 items across math domains based on the task models. So you can see the 4 domains here at the top of the slide with the number of items that we wrote for each. The domains then include a variety of content areas. The examples here are not exhaustive of the progressions, but it gives you a sense of what the content areas were within each of the domains. And the slides you see along the bottom are actual items from the LLAMA assessment, just to give you a sense of what those might look like. Given our time here today, we can't go into great detail around what the actual app looks like, but I'll tell you a little more about it here. So when preschoolers engage with LLAMA, they're introduced to Lolly. You see Lolly the llama here on the screen and on all of the slides. Lolly's a parasocial character that appears throughout the LLAMA app. LLAMA items are presented in 3 adventure contexts. You might have noticed some differences on the slides, on the previous, differences in the images on the previous slide. And so LLAMA items are presented in 3 adventure contexts. Items show up in an outer space context, in an ocean context, in a jungle context. And of course, Lolly is always dressed for the occasion. You can see Lolly's various little outfits there that would fit those contexts. We intended for it to be a game-like experience. It's fun and fun for kids. And we actually tested if the kids liked the context, and if they performed differently, if they were able to choose their context or not. And then the amount of time they engaged with items in different contexts. And the short of it is that the kids liked all of the contexts. And the choice of context, whether the items were presented in an ocean or a jungle context, it didn't affect performance, but it did affect engagement, in that if children chose their context, they did complete more items. They wanted to persevere a little bit longer. Now, when preschoolers interact with the app, they begin with training tasks. So they learn how to engage with the touch surface and complete the item, so that we aren't assessing access, for example. So in this game-like format, preschoolers are taught to touch, to drag, to rotate. They learn and practice all the fine motor movements that are required to complete the images, how the tasks, how to make images glow or make them move, for example. So they're trained up on all these actions before they actually interact with the test items. And then they're taught to advance the slide using an arrow on the screen. We've tested if preschoolers can engage independently with this task, and we're still not there. There's always an adult sitting there, though we've tried to build in some opportunities to move toward independence at this, at the present time anyway. And so then during testing, Lolly actually appears every 7 items or so with a little dance and song, a brief brain break. And items are delivered via a computer adaptive test. Completion takes about 15 minutes or so. Now, participating in a measurement grant is kind of a long game because it takes years to be able to tell a parent or a teacher about the participating child's performance. Soon we'll have item reliabilities and cut scores, but in the meantime, I just wanted to share with you how we've been communicating with families about this. We take our school partnerships very seriously, and while we're building the plane, it's difficult to tell much about outcomes, but we have been providing using our learning progressions. We've been providing these types of summaries to teachers and educators, teachers and families about how children are progressing in their math skills in terms of what they've accomplished and what skills are emerging. And we're able to do that based on the items they complete along the learning progressions. And so this has been a nice, relative to some of the other measurement projects I've worked on, this has been a nice, way to engage with families. An ongoing evaluation of the technical adequacy of LLAMA has been positive. Item and scale correlations are strong. We've been able to retain a very high number of the items we wrote, which is somewhat unusual. Both the items tend to seem to be appropriate and functional for preschoolers based on the way they're engaging with them and the feedback we get from educators and experts. And technically, the items have good differential item functioning. And we surmise that these strong results, retaining most of the items we wrote, are probably due to our care in writing items that correspond with what we know about the kind of learning progression of the skills for children across the key domains. And along the way, we've also tested the delivery of items in blocks. So children completing a bunch of numeracy items and then a bunch of shape and space, for example, versus mixed presentation of items where the items might be mixed across the domains or interleaved. And this is important because you have to collect a lot of data on the items in order to operate a computer adaptive test. And so we've tested out a few other things along the way, like how preschoolers engage in the way that the items are presented. And more or less, the items show that the administration format doesn't really affect performance, though children show sustained engagement, more so with the interleaved or the mixed items. And this just gives us confidence moving toward a final computer adaptive testing platform here with our final data effort, which is happening soon. As we near the end of our project and also the end of these slides, we've learned that LLAMA can collect meaningful information across 4 domains of early math. Preschoolers, teachers, experts all agree that LLAMA is developmentally appropriate and engaging and feasible for administration in preschool. So this has been a super fun project, actually. I mean, who doesn't like llamas and parasocial characters? But of course, the technical feedback is also quite encouraging. And, I feel like we've also done some good work along the way. So we're moving into the final months of LLAMA development to finalize the items for the computer adaptive test. In this final push here, we'll gather and be able to share more data on both concurrent and discriminant validity. With the final app, we will engage in a final project with teachers, with their administration and engagement with a dashboard that will share information about results. And then the next steps really involve pushing into how we can use the results alongside preschool classroom instruction, since that's really our purpose. It's going to be an exciting, final year effectively. So that actually concludes my allocated time for now, and I'm happy to take questions later. So I believe it's AJ's turn, and I'll have to get out of the, okay, I'll just stop. There we go. And I'll pass it over.
Hello, everyone. I'm Demir Lira. I'm an assistant professor in the Department of Psychological and Brain Sciences and Department of Pediatrics at the University of Iowa. And I'm very excited to follow Dr. Missall and Dr. Purpura after their wonderful presentations. I'm going to shift the level of analysis a little bit and talk about the relation between children's home environment and the brain basis of their numerical development. We touched upon this, but we know that despite our best efforts, millions of children fail to reach their learning potential. This is at the forefront of our public discussions, as you can see in the books and newspaper articles on this topic. We again also know that certain children are more likely to fall behind, especially those who come from disadvantaged parental backgrounds. Here's a figure from Reardon and colleagues where they have parental socioeconomic status and sixth graders' academic performance. And what this shows is that sixth graders who come from the most disadvantaged backgrounds are 4 grade levels behind their peers from the schools with the most advantaged backgrounds. We also know that these achievement gaps or opportunity gaps are pronounced in math. As we discussed, these gaps in math emerge early, even before children start kindergarten. They persist over time, and sometimes they predict later important outcomes more than literacy. And this is why across different fields, education, sociology, economics, psychology, many researchers focus on understanding the sources of difficulties, so mechanisms of disparities. This is very important. Today, I want to provide an alternative or maybe additional perspective and focus on instead mechanisms of variations in learning, individual differences. And the reason I want to do this is because there are, yes, at the group level, kids do fall behind, but there are some kids who succeed despite the risks they face. So we want to identify these protective factors that we can hopefully leverage in future supports that we provide. So in our work, we focus on the role of home environment, and we also gain additional information by focusing on the brain basis of children's academic performance. Specifically for math, we focus on the home numeracy environment, its relations to brain base of children's numerical processing, and how this predicts children's performance. Before I get into nitty-gritty details, the main message I would like you to take from today's talk is that children recruit different systems in the brain as a function of their home experiences, even when their behavioral performance looks similar. And I will end by discussing some possible intervention implications of this finding. So our early work in this area focused on school-age children, a broad measure of children's home environment, socioeconomic status. So in these early studies, we used fMRI, which is a brain imaging technique, and we asked 10 to 12-year-olds to solve single-digit arithmetic problems in the scanner as their brains were being scanned. And we asked, is the brain basis of arithmetic processing same or different as a function of parental education, which was our measure of SCS? What we found was that, yes, it did differ as a function of education. Specifically, higher performing children from more advantaged backgrounds tended to recruit these more verbal language areas in the brain. However, higher performing children who came from more disadvantaged backgrounds instead recruited more visuospatial systems and more parietal systems in the brain. So this was our first piece of evidence suggesting that children might recruit different systems in the brain as a function of their experiences, even when they perform on par with their peers. But we wanted to know what are the roots of these differences, when do they emerge, and what are more proximal experiences children have that might lead to these profiles we see, and we focus on the role of the home environment. And we kind of moved back in time and focused on preschoolers. So we know from a rich body of literature that there are developmental changes in the brain as children learn symbolic numbers, Arabic numerals. Specifically, we know that there is increased activation in the left parietal networks as children develop in school years. We also know that there is another shift from more frontal to parietal areas as well. So there's this increased focus on these left parietal regions. But what we want to know is whether these changes vary as a function of children's experiences. To address this question, we brought 4 to 6-year-olds to the lab, and we used FNIRS, functional near-infrared spectroscopy, which is a non-invasive portable imaging technique, and we measured children's brain activation when they were comparing these Arabic numerals and when they were comparing these dots. And to get at the home math environment, we used 2 measures. There are multiple ways to assess children's numeracy experiences, but we focus on the following 2. We gave parents questionnaires asking them the frequency by which they engage in different activities with their children, such as doing math problems in your head, on measuring while cooking. We also observed parents and children interacting around 3 different tasks that were designed to elicit math talk. And we noted down the number of math language parents produce, the number of number words they say, and amount words they say. And this was heavily inspired, of course, by the wonderful work by Dr. Purpura as well. So in terms of age-related changes, we replicated the previous literature. So on the top graph, you see younger children, 4-year-olds, and on the bottom graph, you see 5.5, 6-year-old children. As we were predicting, there's this decreased activation that really focuses on the left parietal areas. This is for Arabic numeral comparison, symbolic number. But what we want to know again is how does this vary with experiences children have? So in this graph, I have child age on the x-axis, and we have children who have richer numeracy experiences at home versus lower levels of numeracy experiences and middle. And I'm going to present different lines tapping onto each brain area we focused on. But I would like you to focus on this solid red line that represents the changes in left parietal regions. So what we see for children with rich numeracy experiences is exactly the pattern that was shown in the prior literature as a general developmental pattern, right? We see that as children, for older children, there's increased activation in left parietal regions and decreased activation in left frontal. Okay. But what's interesting is that we see a different profile when we look at children who have lower levels of numeracy experiences at home. For these children, if we look at the blue line, with age, we see increased activation in left frontal, and if anything, we see some decrease in left parietal. And finally, children in the middle seems to be kind of in the middle in terms of their brain profiles as well. So what does this mean? It looks like, again, children might be recruiting different systems in the brain as a function of their experiences. So does this mean that maybe instead of providing an intervention that's one size fits all, we might need to provide different supports for children to succeed? For example, is it possible that children would benefit from a visual spatial support to different extents based on their environmental experiences? One type of visual spatial support we frequently see in numerical contexts are hand gestures, right? They represent numbers, or they are used to highlight numerical information in different contexts. So we wanted to know, could we support parents' use of hand gestures, which in turn might have implications of the input they provide and ultimately children's outcomes? This is very kind of early work in collaboration with my colleagues from Turkey. But what we do here is a 6-week parent administered book reading intervention where we send parents to books in 3 different conditions. In the first condition, we send parents books with these illustrations, but the book content doesn't have any numbers in it. This is our control condition. In the second condition, we send books and the language has numbers in it. And in the third condition, which is of most interest to us, we send the books and we encourage parents to use their hand gestures as they are reading the books, and we provide with different examples. So what do we see? At the beginning of the intervention, there doesn't seem to be a significant difference between the 3 groups. Each color represents the 3 groups I mentioned. But after the intervention, we see that there's a significant increase in the group of parents who were encouraged to gesture in terms of their parental math talk. I should also highlight that there were no significant differences in the overall amount of language they produced. So this was specific to the math language they produced. And we are currently in the process of examining implications for children's performance as well. But to sum up, I hope I was able to convey that our research suggests that children might be recruiting different systems in the brain as a function of their home experiences. We think these findings might be important because instead of taking high SES children as the gold standard, possibly it might encourage us to develop targeted and effective interventions that better match children's profile so that we can support all of our children to reach their full potential. I would like to end by thanking the families that came, our collaborators, the lab, and our funding sources. Thank you.
Great. We now have some time for some questions. I believe Janelle has some guiding questions.
I
for us.
do. My mouse was playing tricks on me, so I couldn't unmute. But I'm Janelle Williamson. I help coordinate the Big Ten Early Learning Alliance. So we just wanted to round up our multi-level view of math learning with some key takeaways and some guiding questions, and also open it up for Q&A. So if you have questions specific to a certain presentation, please add them to our Q&A there. So really quick, just some key takeaways. So starting with Dr. Purpura's presentation, we saw that states should consider aligning early math standards. And then moving to the classroom level with Dr. Missall, we saw that math assessment in preschool can be fun and instructionally relevant. And then with Dr. Demir Lira, that children recruit different systems in the brain as a function of their home experiences. So for our first guiding question, I want to ask, how might your research findings directly impact young children's math development? So we can start with Dr. Purpura.
I have to find the audio button to unmute.
Yeah.
For us, with these with this specific work that we did on standards, for us, I think that it's really laying comparable foundations for expectations for children. Given there is actually a fair amount of consistency across states at the kindergarten level. Over a decade, well, I guess a decade and a half ago plus, there was a Common Core standards movement that did kind of synthesize across the vast majority of states, and even states that have moved away from using Common Core and have created their own. They're very much largely the same. And so, but I can at preschool or for early learning standards, they're still very different, and so that makes that it may make that transition between preschool into kindergarten more complex in different settings. And so, having an aligned set of expectations across different states, as well as making sure that they're data based and based on what kids can do and are appropriate but challenging, I think can better set a strong foundation for kids in the long run.
Yeah, that's great. So having these consistent data-based expectations could help that prepare children for their future schooling and development. All right, so Dr. Missall, how might your research findings directly impact these kids' development?
Thanks, Tina. I think when I think about math development for preschoolers, kids develop skills in a couple of ways. That children learn math both in informal context learning, like through books and play and interactions, and then they also require some formal instruction to learn some of the skills that are required. Some early math skills are constrained and some are unconstrained, meaning, for example, when children know what the squiggle, numeral squiggle is a 3, for example, then they have that knowledge and they can use that constrained information to access additional information in math, but they have to be taught that. And so I think one of the really useful implications for impacting, how we're interacting with preschoolers is having more depth of knowledge about what's the essential skills that are important for preschool math development. And ultimately then providing information to educators about what they can teach the children to help fill in the gaps. So when we have information about what children know and what they need to know, we can backfill that in a really meaningful way so that children are developing all of the key skills they need to be able to move into, in my thinking, move into formal instruction in kindergarten and moving ahead and access that curriculum. So it's fun to have the little assessment, but the purpose of it, the impact is really much broader in thinking about how early development connects with learning. This is just one little simple tool to help educators get more information about where kids are along that pathway, I think.
Yeah, so understanding where the kids are at in their math development and informing the teacher on that directly so that they can step in and see and fill in those gaps to prepare them again for future schooling.
Yeah, that's exactly right. Because the predictive validity of the skills is quite strong for accessing learning later on. So thinking about how to do it in a fun way, is good.
Yeah, with Lolly the Llama, love it. All right, Dr. Demir Lira.
Yeah, thank you for the question. I think one of the possible paths for impact is, again, better acknowledging maybe the role of parents, right, before formal schooling, which we have big literature highlighting this as well, and trying to identify what supports we can provide to parents so that children come to preschool environments most prepared. Is one of the direct impacts. The imaging findings, I think, more indirectly impactful. I think they are informative when they are combined with carefully measured behavioral assessments such as the LLAMA. So I think imaging findings provide additional information about the essential skills or where kids are at, and important to provide maybe another level of information that might provide additional information than what we can get from other measures. So I think imaging findings are indirectly impactful, and their synergy will be higher when they are combined with other measures as well.
Yeah, that's great. So understanding a home learning environment helps us understand how to support parents before their kids are in school or while their kids are in school. And yeah, those imaging studies can get more at the individual level of what's going on in a kid's brain as they're learning this math.
Yep.
Thank you. So our final guiding question, and then we'll open it up to our audience. Do you have any policy or practice recommendations based on your findings? If you haven't touched on that already. So again, Dr. Purpura.
I mean, I would probably say for the first one, as states start to revise their early learning standards, I think that it would be important for them to work together to create more consistent evidence-based standards.
Yeah, so collaboration across states would be an important policy implication. Kristen?
Yeah, thanks. I could come at this from a variety of ways, but I think the most impact for the use of LLAMA will be with early educators in the classroom, and in terms of what we're hoping to see in terms of uptake amongst early educators is really both thinking about the math instruction they're delivering, how it could be, modified in different ways for groups and individual children, and then how they can be more intentional about providing that input so that children can learn the key skills they need for later on, and then really getting excited about database decision making, using information to actually impact their practice in a very productive and naturalistic way. Sometimes I think assessment gets interpreted as somebody doing something right or wrong, and we hope to see this as more of a support for educators and just doing more in math.
Yeah, so again, like that key finding of accessible and fun assessment that's not burdensome for teachers, but really impacts their instruction. And then finally, AJ, Dr. Demir, Lira, any policy or practice recommendations based on your findings?
Yeah, I think one interesting recommendation would be, when we go to pediatricians, they have some comments about reading, literacy. So could we enhance these recommendations also to focus about math and numbers? Sometimes parents don't feel comfortable bringing math, right, to the early home environment. So that would be one policy recommendation based on the findings.
That's great. I would have not thought of that. Thank you for sharing. All right, I'm going to open up our Q&A and our chat. And this is from our colleague, Dr. Laura Justice for AJ. Why would different volumes of home numeracy activities lead to brain-related differences in young children?
Yeah, that's a great question. I think that the home numeracy environment that we capture might be specifically about children's exposure to more symbolic numbers, right? Either in terms of language or in terms of exposure to formats of Arabic numerals. We did not see associations to non-symbolic number processing in the brain. So I think that aspect of home numeracy is the one that's leading to increased specialization of left parietal networks for symbolic numbers specifically. So I think that component.
Thank you. I have a question for Dr. Purpura. With the recommendation that states work together, how do you actually make that happen? How do we get states to work together on these standards? Any advice there?
That's a complicated issue. But I think there are multiple tracks that need to be taken. I think those of us that do have direct working relationships with folks in our state continue to communicate with them, share these ideas with them, and when there are opportunities for revisions to be made. I know some states have just made revisions, others haven't made them in 5 to 8 years. That they raise these issues with the folks who are at their state agencies. I think the other part of it is through efforts like what the Big Ten Early Learning Alliance is doing overall, connecting those of us who are researchers in the field in early learning to help talk with a stronger voice about critical things that are needed. So I think those are a couple of the tracks. I think also making sure that when I've talked to folks about this variability, they seem to recognize, this is something that needs to be fixed. I think some of it is that we don't know what other states are doing unless we're talking about it. And so I think this talking about it now and through the brief and other settings might be that first step in getting people to listen and understand that there is actually a challenge here.
Mm-hmm. Awesome. Thank you. Thanks for starting to spearhead that work in our group as well. We just got another question in. Knowing the importance of play-based learning, how do we get parents to buy into this theory? So many think that worksheets or flashcards are the best way to learn. Any thoughts on interacting with parents about math learning?
I can take that one. Yeah, we've actually done some of that work. And I'm not sure there's one answer, Janelle, but we've done a couple of interesting studies embedding both kind of some of this discrete skill learning as well as vocabulary. That's the other important access point. Imagine a kindergartner sitting in a classroom and the teacher says, okay, we're going to make patterns, and the child they may know how to do a pattern, but they can't access the task because they don't have the vocabulary. And so, in fact, one of my graduate students, I think, is on the call. She's done a couple of really cool studies embedding some of this numbers, for example, into books and drawing kids' attention to those numbers, or engaging in vocabulary instruction. Let's make a pattern with these toys, or board games. There's great research on how board games can help kids to learn can counting up and counting down, not the board games where you just move to the color, you move 3 over and over again, but board games with counting up math. So there are some natural environments. Actually, there have been a couple great studies using snack time in preschoolers to count out. It's highly reinforcing. If something comes with M&Ms, I'll learn it. But anyway, some of those, when we do parent workshops, we talk a lot about those natural opportunities and interactions to fold in both some of that discrete skill learning as well as access to vocabulary. And I think my colleagues have other expertise too in that space.
Great, thanks. Next question here. Any recommendations to facilitate math talk in classrooms with bilingual children? Are there bilingual books that we can use?
I'm in the middle of typing a response to that, but it'll
Oh,
be
great.
just to share. I'm a slow typer. So we're actually in the process of developing some children's books that are really focused on early math language, words like more, many, most, a lot, same, similar, different, those types of words. And we've built in dialogic reading prompts into the books that parents and teachers can use to engage their children or students in questions around early math. And our English versions of a few of the books are already available for purchase on Amazon. You can find them by going to our website, www.thelittleelephants.com. That gives a little bit of the information behind them and the links to Amazon. And we're actually cleaning the data right now from a large randomized control trial study with dual language learners, where we compared our version of the books in Spanish, as well as an ebook version of the books in Spanish with a comparison group. I don't have those findings right now, but we're hoping to finish cleaning those data in the next couple months and analyze the summer, and hopefully get those books disseminated this summer. And so, but there are a lot of neat things to think about with math and math language with dual language learners that need to be taken into consideration. There are a lot of words that don't directly translate, especially math specific words, like the word most, for example, doesn't really directly exist in Spanish. You would say la más, which is the more, or la mayoría, which is the majority, and those don't directly translate. And so there's some work that we're trying to or that we're doing right now to try to figure out the best way to work across both languages for supporting early math development, but it's still in the process.
Awesome, thank you. Let's see, we have a question from Benjamin. Are there any policy reforms at the state level active across the Big Ten states in early numeracy standards? And if so, are there any state-based advocacy groups leading the charge? So do we know of anything happening in this space in our states?
I was on mute, sorry. Not that I am directly aware of. I know that I've worked with our state in the past on revising standards, or then they called them foundations and not standards. But I think things come up at different times. I know that Maryland is currently finalizing their revisions to their most updated standards, but I don't know of any specific advocacy groups.
Thank you. We have a couple questions for HA. One of them is, would you expect that the different developmental profiles of neural activation you find during numerical tasks would be associated with differences in types of mathematical interventions those children might respond to?
Yeah, so I don't have empirical answer. I would love to collaborate with intervention researchers on it. That is the prediction, right? We would argue that those who maybe are not exposed to home numeracy to a high level might benefit more from an intervention that includes visual spatial support, which there are behavioral studies consistent with this as well.
Awesome. And then our last, I'm going to wrap it up with this one from the chat. again for AJ. With the findings that high-performing individuals with low SES backgrounds are usually visual and those with high SES are usually verbal, would it be possible to do a somewhat quasi-experimental study where after, this is long, sorry, after gathering demographic information, making each child's condition different? Like one intervention is more wordy for the possible verbal bias kids, and the other is very picture-based with an emphasis on gestures. So that was long. So it's in the chat if you need to read it.
Yeah, so again, I think there's a big, like kind of a lot of steps before we can go to intervention. So I want to highlight that. I think neuroimaging data is another layer of information. What that would be consistent with what I would predict, but I think there are multiple steps we need to take to link the imaging data to the intervention, but that would be the overall prediction.
Wonderful. Well, thank you all for sharing your expertise. I know we were excited to share about all our math expertise, and I'm glad we found a way to connect it all together. So thanks again. When our audience leaves the Zoom, you'll be directed to a really short survey. So please take that to give us feedback on this event and also help inform future events. And yeah, we'll send out the recording and resources within a week. So thanks for being here, and we'll see you all next time. Bye.